For our next problem, we'll solve a radical equation. In this equation, we have two radicals, and we need to isolate one of the radicals before we start. So let's take the second radical, the square root of x minus 1, and move it to the right-hand side. And we'll get the square root of x plus 4 is equal to 5 minus the square root of x minus 1. Now, in order to remove the radicals, we'll need to square both sides of this equation. When we square the left-hand side, we just end up with x plus 4. On the right-hand side, I'm going to actually write this out as 5 minus the square root of x minus 1 times that same quantity again, 5 minus the square root of x minus 1. This will make it a little bit easier when we FOIL. So on the left-hand side, we just have x plus 4 equals, let's see, 5 times 5 gives us 25. The outside terms give us negative the square root of x minus 1 times 5, so that's minus 5 times the square root of x minus 1. The inside terms also give us minus 5 times the square root of x minus 1. And notice the last two terms, negative times a negative is a positive. The square root of x minus 1 times the square root of x minus 1 is just x minus 1. Now on the left-hand side, we have x plus 4 is equal to, on the right-hand side, notice I have 25 minus 1. I'll combine that and get 24. Then I have negative 5 times the square root of x minus 1, and another negative 5 times the square root of x minus 1. That's negative 10 times the square root of x minus 1. And then I still have plus x. Now notice in this case, even though we squared both sides of our equation, we still have one radical left. We have this radical right here, negative 10 times the square root of x minus 1. So I'm going to leave that on the right-hand side and move all the other terms to the left-hand side. So notice, if I subtract x from both sides of the equation, there will be no x term left. I have 4. When I subtract 24, I'll end up with negative 20 on the left-hand side equals negative 10 times the square root of x minus 1. Now before we square both sides of this equation, let's go ahead and divide both sides by this negative 10. And we'll have a simpler equation. We'll have 2 is equal to the square root of x minus 1. Now we're ready again to square both sides to remove the radical. When we square both sides, on the left-hand side we have 4 equals, on the right-hand side, the square root of x minus 1, that quantity squared, just gives us x minus 1. So we have the potential solution when we add 1 to both sides that x is equal to 5. But I need to check this solution in the original equation to make sure that it's not extraneous. So let's check this solution, x is equal to 5, by substituting 5 in for x in my original equation. When I do the check, I'll have the square root of 5 plus 4 plus the square root of 5 minus 1. Is that equal to 5? Let's check. The square root of 5 plus 4 is the square root of 9, which is just 3, plus the square root of 5 minus 1 is the square root of 4, which is just 2, and that is equal to 5. That's a true statement. So I'm ready to state the solution. The solution set is that x is equal to 5.